Hello, this is Dr. A. We're going to be talking about solar radiation Earth seasons in section 4.7. One of the main ideas is that insolation is the amount of solar radiation or energy that reaches an area. It's measured in watts, which is power per square meter. So, the learning objective here is to explain how the sun's energy affects Earth's surface, going from what is insolation, the angle, highest energy per unit, and so forth. Suggested FRQs to describe the characteristics of an environmental concept, process, or model. So, solar intensity and latitude. As you can see here, this is equally spaced. However, sunlight that strikes at the equator is in a concentrated area, whereas the same amount of energy heating up here is over a larger area. Therefore, they each have the same amount of watts right here, but when it's over a square meter, it's spread out more. So the solar intensity of insolation depends on the angle. The higher the angle up here towards 90 degrees, the more area it's going to be spread over, whereas at the equator it's very concentrated. The amount of atmosphere's sun rays that passes through. Here, it just goes through this small amount. Here, it's at a higher angle, and therefore, it's going to be more of the blue light, for example, is going to be filtered out because of the light, making the atmosphere blue. Equator, higher insolation than at higher latitudes. Here we can see that it's coming in, all the same amount coming in, but here it's more diffuse than here. There is actually 2.5 times more energy at the equator than at the poles. Why? Even though it's the same amount coming in, it's spread over a much, much larger area. So how does the solar intensity affect the seasons? The amount of orbit of the Earth around the sun and tilt on the axis changes the angle of the sun's rays. This causes varying insolation, varying length of day, and seasons. The tilt of the Earth's axis stays fixed during orbit. However, because of the tilt of the Earth, it changes. During the solstices, June and December, you will notice here in December, the northern hemisphere is pointed away, and therefore it's dark, oftentimes 24/7. Here, it's going to be dark 24/7 on the south equator. Up here, during their summer, they will have a lot of times where it's going to be light 24/7 in the northern hemisphere. Over here, it's going to be 24/7 light in the southern hemisphere. March and September, equinox, meaning equal amount, northern and southern hemispheres are equally facing. They're the same angle. Earth is closest to the sun on January 4th. And so the seasons is not caused by how close we are to the Earth, to the sun, but how much the tilt is facing. And so here there's going to be more of the northern hemisphere hit, less of the southern hemisphere. Exactly opposite here. Now, one of the things that you need to know is what happens at various locations. Notice that the direction here at March equinox, equator receives very, very concentrated, the most direct. Northern and southern hemispheres get 12 hours of sunlight, and it's spring in the north and fall in the south. How do we know that? Because over here, it's now summer in the north. How do we know that? Because right here, a lot of the right around the North Pole is light. Why? Because it's tilted towards the sun. The longest day in the north in late summer, shortest day in the south during the winter. Now notice it goes from fall to spring to summer. What would it be over here? For the northern hemisphere, it would be fall. The equator receives most direct insolation, just like in spring. It gets 12 hours of sunlight, and it's fall in the north of spring. Over here, it's December. Why? Because we see that it's dark right here. It's the longest day in the south, and therefore the shortest day in the north. Tilt of the Earth's axis depends on the angle of insolation, which causes the tilt of the Earth's axis causes variation in the angle of insolation, which causes the intensity. Therefore, it causes changes in length of day, the season. Another thing that affects the temperature of the Earth is something called the albedo effect. The albedo is the portion of light that is reflected by a surface. Surfaces with high albedo reflect more light and absorb light. For example, snow, it's white. White is the reflection of all light, and therefore very little is going to be absorbed. Most of it's going to be reflected. Surfaces with low albedo, for example, a black sweatshirt, reflect less light. Black is the absence of light, therefore it basically doesn't reflect any, and absorbs a lot of it. Because it absorbs it, when it's re-emitted at a lower frequency, which is infrared. Albedo and surface temperature. For example, surface temperature is affected by albedo. When sunlight is absorbed, it gives off infrared heat, which warms it up, the area around. Areas with low albedo absorb more sunlight, such as the black parking lot. It's going to have a lower albedo, it's going to absorb more, and therefore it's going to keep more energy in it, as opposed to reflecting the light. Chlorophyll absorbs red and blue, gives off green. Therefore, when these two colors of light are emitted, they're emitted at a lower frequency, which is infrared, because they've lost energy, causing the chlorophyll to vibrate and making food. Urban heat island. Urban areas are hotter than surrounding areas because low albedo of the blacktop. Polar regions are colder due to higher albedo. So, FRQ 4.7. Can you identify which season is taking place in the northern hemisphere in this diagram? And 2. Can you describe how the tilt of the Earth's axis is responsible for Earth's seasons? Thank you, and I hope this has been helpful.